All right, part 2 here of 10.3, Introducing Logarithms. Before we go any further, I need to talk about some special logs, some special logarithms, and the notation that goes along with them. So the first of two special logs is the common log, is its name, and it looks like this. It looks like simply the log of x. And what you notice is they didn't write a base. There's no number down there in the subscript. So what is the base if you don't write it? Well, it turns out it's 10. The common log, if you don't write any base, everybody knows you mean it to be 10. You don't have to write it there. So, and you think, well, what's common about 10? Well, it turns out our number system is base 10. We have digits from 0 to 9. And then once we hit 10, then we start combining those digits together. So hence why this is the common log. The common log has base 10. We see that in other cases in math, right? You know, if you've got just x, that's implied to be x to the first. You don't have to write the 1. We know it if it's not written there that it's to the first power. Same thing here. If the base is not written, then we know that it's a base 10. Okay. The other special log is the natural log. And you might remember the natural number. So here it is. The notation for the natural log is ln of x. And usually when you write it by hand, it's in cursive. ln of x, the natural log. I think it's originally in Latin. And so the adjective is in the second position, the logarithm natural. That's how they would say it. ln of x. The natural number, you might remember, is that number e, that strange number e that we saw back in 10.2. So nobody writes it as the base, but if you're talking about the natural log, everybody knows that that base is e. Okay, I have a couple more examples following from the previous video to determine the value, and we're going to use our special logs for these. So what if I wrote part C of that same example? What if I wrote the log of 1 over 1 million? The log of 1 over 1 million. So you might say, okay. Well, I know that if there's no base written there, that it's a base 10. And oftentimes students like to go ahead and fill that in because it makes thinking through the next step a little bit clearer. Okay, so if I've got base 10, so remember how we're going to go about this. We're going to say, all right, log base b of x equals y. So I can rewrite this as b to the y equals x. I know my base is 10. 10 raised to what power would give me that number right there, the 1 over 1 million? Oh, and it looks like I'm giving it away. I didn't mean to do that. 10 raised to what? So for 1, we can see that there are 6 zeros. So maybe you would agree that 10 raised to the 6 is 1 million. All right. But we don't just have 1 million, we have 1 over 1 million. So we have to make that a negative, so it takes the reciprocal. So 10 to the negative 6 equals 1 over 1 million. And then we can say, all right, that original logarithm we were asking about, we figured out the y. So that whole thing simply equals negative 6. Now, if you like, it turns out every scientific calculator has the common log. And so I'll show you guys here on mine. So mine is up right underneath the second button. I know it's really fuzzy. I'm getting a reflection there in my that's the camera, I think, right up there. Okay, anyway, so I'm going to hit that button, turn my calculator on, hit that button. I have to hit it twice, and then I can type in 1 over 1 million, and there it is. So obviously, if you've got an older calculator, that button is if it's a TI, it's likely still in this left column somewhere for the log. And you can just put that number right on in there, and it'll tell you what it is. This one comes out to a nice whole number. It won't be the case always. Okay, I've got one more of these. This one uses a natural log. Okay. The natural log, and the argument here is e to the third, the natural log of e to the third. Well, if you remember, the base for natural log, it's not written, but it's a base e. So for this question, we'd be thinking, okay, my base is e, so I'm saying an e to the what? E to the y equals 3. E to the third, excuse me. E to the y equals e to the third. Like, okay, what does y equal? Now this one, it's like so obvious that students may end up tripping up or almost like laughing at this point. So, all right, if our base is e raised to what gives us that argument, e to the third? Well, of course, doesn't y have to equal 3? So there's my answer right there. The y is, it's got to be e to the third equals e to the third. So I know that the natural log of e to the third equals that exponent I just figured out, 3. And that's right. If you look on your calculator, you've got a natural log as well. Any scientific calculator has a natural log in it. Mine is right there. And then I've got my e to the third. The natural log of e to the third is 3. Very nice. Very nice. Another way to think of natural log and e is they cancel each other out. They're inverses. Ooh, okay. So natural log and e cancel each other, and we just get the 3. That'll come up more so in the next section. Okay, so now we're done with the finding the value questions. Let's solve. This will be good. Okay, solving. So here's our first problem. We've got this logarithmic equation, you would say. It's the log of x plus 2 with base 5 equals 4. And so we recognize we are given something in the logarithmic form. Although here, we don't just have x, we have x plus 2 in there for our argument. But we can still follow this pattern. We're going to begin by rewriting it in the x equals b to the y form. So if we just match all the parts, I've got, that's my x, if you will, x plus 2. I've got my b, I've got my y. So following the same pattern, x plus 2 equals 5 to the 4th. Okay, so I'm rewriting it in the exponential form. I mean, that's what we're doing this whole chapter, or this whole entire section, is just using that rewrite powers. And once we get to here, hey, we're pretty much home free. Let's calculate 5 to the 4th. I think we saw that a couple problems back. It's 625, and we subtract 2, and there's our solution. X equals 623. Okay. I think I got one more for us. This one involves a natural log. Oh, can I line it up there on the page? All right. The natural log of x equals 7. So I'm going to think of it as being in this form. My y is 7. X is simply x. The base, well, if you remember, for natural log is e. So if I rewrite it, in the x equals b to the y form. Oh, looks like I just went ahead and wrote that. So make it really, really clear. Okay, there's my base. Rewriting this, I've got it, right? The x equals my base raised to the y, x equals e to the 7th. And I have the answer. You notice here my note to the side. This is the exact answer. E is, of course, a decimal that goes on forever. So e to the 7th would be the exact, the way I would represent the exact value of my answer. However, sometimes we like to have rounded answers. They're kind of strengths and weaknesses to both. So if you put e to the 7th into a calculator, you will get that number right there. There I rounded it to 4 decimal places, which is a pretty common thing to do when it comes to exponentials and logs, 4 decimal places. We'll see that in homework, I believe is the way they do it too. So there you go, 1096.6332. That's the number that would need to go here so that the natural log of that number would give you 7. Rather big number for the natural log to just be 7, but that's what it is. Okay, that's the end of the lecture. So I've got one more video for 10.3. I'm going to give you guys a couple of problems to simplify, to find the value, to solve. So take a look at that, and then we'll see the solutions to those as well. See you there.